Something extraordinary has just happened. For the first time in modern history, the James Webb Space Telescope has captured a chain of discoveries so strange, so precise, and so connected that it forced scientists to rethink everything they believed about how life begins. Across a few weeks, the telescope recorded crystalline ice forming around a young star, rings of carbon dust swirling around a planet, and chemical signals that should not exist under any known laws of physics. But none of those alone were what stopped the world. It was what came after, what Webb found hidden between stars, deep in alien atmospheres, and buried inside the molecules that built the universe. It all began with a young sun-like star named AID 181327, a bright point just 155 light-years away. Through Webb's near-infrared vision, astronomers looked into the dusty ring of debris surrounding it, the kind of ring that marks the beginning of planet formation. But what Webb saw wasn't just dust. It was glittering, structured, reflective. The entire disk shimmered with crystalline water ice. It wasn't scattered randomly either. It was bound to grains of dust, forming what scientists now call dirty snowballs. And when they measured the mass, more than a fifth of it was ice. For the first time, we could see the ingredients for oceans forming not on a planet, but around a star itself. These weren't remnants from collisions or fragments from ancient comets. They were seeds of water, waiting before worlds even existed. The system was only 23 million years old, still in cosmic infancy. Yet water was already shaping its future. For decades, we believed water came late, brought by comets after planets cooled. Webb proved the opposite. Water was there from the beginning, silently weaving itself into the story of creation. In that ring of ice and light, we were watching the first chapters of oceans being born. But while Webb uncovered water around a newborn star, it found something even stranger somewhere else. A young gas giant, CT Chabi, orbiting a dim sun 600 light-years away. A planet so massive and so hot that its glow reached directly into Webb's sensors. But that wasn't the surprise. The surprise was that this planet had its own disk, its own miniature system of dust and gas swirling around it. A planet with a debris ring, just like a star. Inside that disk, Webb detected something alien. The chemistry wasn't icy and it wasn't simple. It was carbon-rich, dominated by reactive compounds that could form the backbone of life. It was the first time anyone had seen carbon forming in the orbit of a planet, not a star. That discovery changed everything. It meant the chemistry that gives rise to life could begin in places far darker and smaller than we ever imagined. Life's ingredients didn't just need starlight, they could emerge from shadow. As data poured in, Webb moved on, its golden mirrors turning toward a faint brown dwarf named Wolf, 1130. C, a body too small to be a star, too large to be a planet. There, buried in the spectral lines of light, scientists saw something that made them stop breathing. The unmistakable signature of phosphine gas. On Earth, phosphine comes from two sources, microbial life or human industry. Nothing else produces it in such abundance. But Wolf 1130C wasn't supposed to have life. It wasn't supposed to have energy at all. It was a failed star, a husk of gas and metal cooling in silence. There should have been no sunlight, no warmth, nothing to spark chemistry. And yet, there it was, a signal so clear it couldn't be denied. Scientists scrambled to explain it. Maybe exotic reactions in metallic clouds. Maybe chemical lightning. But the data didn't fit. The ratios were wrong. The gas persisted for too long. Something was replenishing it. The discovery echoed an old mystery, phosphine once detected in the clouds of Venus, and later dismissed as error. But this time, the readings were irrefutable. Webb had seen it with precision no telescope ever had. Somewhere between a planet and a star, in the dim twilight of Wolf 1130c, a gas tied to life was being made. And that wasn't all. Webb's next observations peered far deeper, beyond local stars, beyond our galaxy, into the early universe itself. In that faint ancient light, it spotted something no one had ever imagined. Dozens of red points flickering between primordial galaxies. They looked like distant stars at first, but their energy was too concentrated, their brightness too violent. They weren't stars, they weren't galaxies, they were something new. Webb's spectrometers revealed the impossible. These objects were both stars and black holes at once, hybrids formed in the chaos of the universe's birth. Small black holes devouring matter so quickly that they blazed brighter than entire galaxies, wrapped in shells of radiation that made them glow like suns. They called them black hole stars, the monsters that built the cosmos. For the first time, we saw what the beginning of creation might have truly looked like. Not peaceful clouds of dust, but fire and hunger tearing the universe into form. In just a few months, Webb had rewritten the origin story of existence. It had shown that water came before worlds, that carbon could grow in darkness, that phosphine might bloom without sunlight, and that the universe itself was born from violence, not calm. Each discovery was astounding on its own, but together they began to form a pattern that whispered something bigger. Every place Webb looked, from stars to failed worlds to ancient galaxies, carried traces of the same chemistry, the same molecular fingerprints, hydrogen, carbon, oxygen, nitrogen, woven again and again across billions of light years. The same ingredients that built us, repeating like a song the universe could not stop singing. It was as if life wasn't rare or fragile, but inevitable, a process the cosmos performs wherever it can. And for those watching the data come in, the realization was overwhelming. Webb wasn't just showing us new places or distant objects. It was showing us ourselves. Every atom in our bodies, every molecule in our blood, was once part of those same processes. Water frozen around a star, carbon circling a newborn world, phosphine rising in the dark. For centuries, we've looked at the night sky and wondered where life might exist, but for the first time, the evidence was pointing back in one direction, everywhere, and that was only the beginning. Because as Webb kept turning its mirrors closer to home, toward the frozen worlds of our own solar system, it began to see something that would change not just astronomy, but the way we define what it means for a planet, or anything, to be alive. When Webb turned its golden mirrors back toward our own solar system, no one expected what it would find. The great observatory that had just looked back 13 billion years into cosmic history now focused on the familiar, the quiet giants and frozen worlds orbiting our sun. Yet what it revealed there was just as shocking as what it had seen in the deep universe. For decades, Saturn and Uranus had been considered peaceful, predictable worlds. Cold gas giants wrapped in storms and distant from the sun's warmth. But through Webb's infrared eyes they came alive. Saturn's atmosphere glowed with rhythmic pulses of methane, rising and falling like breath. Vast plumes stretched thousands of kilometers high, appearing and vanishing in perfect intervals. When scientists compared the pattern to the sun's own energy output, the data matched exactly. Saturn wasn't random. It was synchronized, pulsing in time with the heartbeat of our star. The implications were staggering. Saturn, a planet more than 1 billion kilometers away, appeared to be responding to the sun's subtle cycles as though connected by an invisible rhythm. It wasn't just orbiting the sun, it was harmonizing with it. And Uranus was even stranger. Its pale blue clouds hid something violent. Webb detected a massive vortex near its north pole, large enough to swallow Earth entirely. Within it, temperatures spiked higher than any model predicted possible. Gases seemed to ignite chemical reactions that generated heat from nowhere, like a self-sustaining engine buried in the planet's core. Some researchers began to whisper that gas giants might not just be frozen relics of the early solar system, but living reactors. Planetary hearts beating in resonance with the sun itself. If Saturn and Uranus were the lungs and heart of the solar system, Pluto and Makemake were its ghosts. Cold, dark, nearly forgotten worlds at the edge of everything. But Webb's vision pierced their icy shells and found warmth. Both worlds emitted faint infrared glows, light that didn't come from the sun, but from within. Beneath their nitrogen ice crusts, heat pulsed in slow, steady waves. On Pluto, the glow rose and fell every few hours. On Makemake, it was constant, like an ember that refused to die. When Webb analyzed the spectra of that light, it found something unexpected: methane clathrates, crystalline cages that trap gas under pressure. These structures form only in environments where heat and chemistry meet beneath the surface. And mixed into those signals were traces of complex hydrocarbons, molecules that on Earth are always linked to organic reactions. That finding shattered everything we thought we knew about these distant worlds. Pluto and Makemake were not dead, frozen rocks. They were hiding oceans, liquid, dynamic, alive with chemistry that could sustain the earliest forms of life. Suddenly, the idea that life required warmth and sunlight seemed outdated. Maybe it didn't need light at all. Maybe life's spark could thrive in the dark, fed by the quiet heat of the universe itself. It was at that point scientists began connecting the dots. Every discovery Webb made, from distant stars to nearby moons, spoke of one thing: connection. Planets breathing in rhythm with their star, icy bodies glowing from within, gases that acted alive even in the cold. Each finding pointed to a cosmos that wasn't a collection of isolated systems, but a single, self-sustaining network, a web of energy and chemistry repeating itself endlessly. Then Webb looked further still, beyond our solar system, into the faint light of exoplanets orbiting distant stars. Among them was K2-18b, a world 120 light-years away. Earlier, telescopes had detected water vapor in its atmosphere, but Webb's instruments could see deeper, reading the fingerprints of molecules hidden in the haze. What it found silenced every doubt: methyl cyanide, dimethyl sulfide, carbon dioxide, compounds that, on Earth, are only produced by biological processes. Together, they painted a picture of an atmosphere that wasn't static or simple, but active, alive. This world, long thought to be a mini-Neptune of gas, appeared instead to be a Hycean planet, an ocean world shrouded in hydrogen, perhaps with liquid seas stretching endlessly beneath its clouds. Then came an even more astonishing detail: the weather. Webb detected changes in light absorption that hinted at clouds forming, dissolving, and returning in cycles. It meant that K2-18b wasn't just a static world. It had rhythm, seasons, perhaps even rain. A world breathing under a sky not unlike our own. It was no longer science fiction, it was data. And then Webb turned toward a system that had long haunted astronomers' imaginations: Trappist 1, the small red sun with 7 rocky planets, just 40 light-years from Earth. For years, we dreamed it might be a miniature version of our solar system, a cluster of worlds that could cradle life. But when Webb looked closer, it saw something far stranger: the Trappist. One star itself was fierce, erupting with violent flares that bathed its planets in radiation strong enough to strip away atmospheres. Yet somehow, 3 of the planets still showed clear chemical signatures of carbon dioxide, ozone, and water vapor. They should have been barren. Instead, they were regenerating. It was as if their atmospheres were rebuilding themselves from within, replenishing faster than they could be destroyed, a planetary defense mechanism no one had ever imagined possible. It defied logic, but the data was clear. These planets weren't dying. They were adapting. And then, in the readings from one of them, Trappist 1e, Webb found a faint trace of nitrous oxide, a molecule that, on Earth, exists mostly because of life. The signal was tiny, nearly lost in the noise, but it was there. A chemical breath drifting through the thin air of a distant world. That one detection, small, fragile, but real, changed everything. For the first time, humanity had direct evidence that an Earth-sized planet orbiting another star might be alive. Not barren, not theoretical. Alive. From water forming before planets exist, to carbon chemistry surrounding lonely giants, to phosphine whispering from failed stars, and now to worlds fighting to survive beneath alien suns. The pattern was impossible to deny. Everywhere Webb looked, it found balance, feedback, rhythm, systems acting not like machines, but like organisms. The universe was not random. It was organized. It was coordinated. It was alive in ways we were only beginning to understand. By the time the data reached the control rooms, silence filled the air. No one spoke, because everyone was thinking the same thing. These weren't isolated miracles. They were pieces of a single truth, that life isn't the exception in the cosmos. It's the rule. And as Webb's final images came through that week, something in the room shifted. Every image, every spectrum, every glowing world began to look familiar. The same water, the same carbon, the same light echoed through every corner of creation. It was like looking into a cosmic mirror and seeing our own reflection staring back. We weren't just observers of the universe anymore. We were its continuation, a pattern written billions of years ago, still unfolding through us. When the final batch of images and data streamed down from the James Webb Space Telescope, the control rooms around the world fell silent. There was no single discovery this time, no single planet, molecule, or galaxy to celebrate. What Webb had given us was something much larger, something that tied every fragment of its mission together into one realization. It wasn't just revealing what existed out there. It was showing us what we are part of. For months, astronomers had been cataloging individual wonders, water forming before planets, carbon swirling around a world that shouldn't exist, phosphine glowing in the dark between stars, and chemical storms on gas giants that seemed to breathe in rhythm with the sun. But as the data continued to arrive, a pattern emerged. Every discovery echoed the same idea. The universe was not a collection of isolated systems. It was a network, vast and interconnected, governed by a set of rhythms that repeated across space and time. Everywhere Webb looked, the same ratios appeared. Hydrogen, carbon, oxygen, nitrogen, the 4 building blocks of life surfaced again and again, organized into the same structures, reacting in the same ways, across distances that light itself could barely cross. The same molecular patterns that formed us on Earth were forming still, in places we had never imagined life could exist. Scientists began to call it the synthesis epoch, a new era of understanding where physics, chemistry, and biology merged into one. Life, it seemed, was not a rare byproduct of the universe. It was the universe's default state. From the birth of stars to the decay of comets, the cosmos wasn't indifferent, it was creative. Then came the final link, the one that turned theory into revelation. Webb's instruments picked up faint light from galaxies so old they existed just a few 100 million years after the Big Bang. Their structures were impossibly mature: spiral arms, dense cores, and star clusters that shouldn't have formed so soon. According to every model, there hadn't been enough time for such order to exist. Yet there it was, symmetry born out of chaos, precision emerging from the void. The deeper Webb looked, the more it found that same balance. The same constants that shaped our solar system were at play in the very first galaxies. The chemistry of our oceans matched the spectra of interstellar clouds. Even the faint radio waves that hummed through the cosmic background carried harmonics that mirrored the resonant frequencies of biological molecules. The math was no longer coincidence, it was communication, a pattern threaded through the fabric of everything. That realization spread beyond the laboratories and observatories. Philosophers, physicists, and even poets began to speak the same language again, one that humanity had forgotten long ago: the idea that existence itself is alive, that the universe doesn't just host life, it generates it, sustains it, and perhaps even seeks it. Webb had shown us a cosmos that behaves like an organism, self-regulating, adaptive, and endlessly creative. Every discovery pointed to feedback loops, cycles, and pulses of energy that echoed in perfect synchrony from the smallest molecules to the largest galactic structures. It was as though the universe was breathing, its inhale and exhale measured in eons, its heartbeats written in starlight. And when scientists overlaid the data from distant exoplanets with the atmospheric patterns of Earth, something profound emerged. The rhythms matched. The fluctuations of light and chemistry on worlds hundreds of light years away resonated with our own planet's seasonal and magnetic cycles. The implication was unthinkable. Earth was not an anomaly. It was in tune with the universe itself. As more evidence came in, one truth became unavoidable. Life wasn't waiting to happen. It was happening everywhere, all the time. Not necessarily in forms we'd recognize, but as a universal process, a law as fundamental as gravity. The cosmos wasn't empty. It was full of experiments, each world a variation on the same theme, each star a spark in the same living equation. And that realization changed how we looked at ourselves. The same frozen water forming around a young star today once rained down on our world billions of years ago. The same carbon dust swirling around alien planets became the bones, blood, and breath of everything alive here. Even the phosphine web found in the dark belonged to the same family of molecules that shaped our first cells. The universe hadn't just made us, it was still making us. That's what scientists meant when they said Webb had stopped the world. For a brief moment, humanity paused and saw itself not as separate, but as part of a single ancient system that had been creating and recreating life since the beginning of time. The telescope's golden mirrors hadn't just reflected light from distant galaxies. They had reflected us, our origins, our essence, and our connection to everything. The conclusion was both beautiful and terrifying. If life is woven into the structure of the cosmos, then so is death and rebirth and every cycle in between. The universe doesn't favor one world over another. It builds, destroys, and builds again, endlessly, like a pulse that never stops. And in that endless rhythm, we are not spectators. We are participants. The scientists who first saw the data said it felt like standing in front of a mirror that stretched across time. Every pattern, every molecule, every equation was part of one vast reflection. The telescope had shown us not what lies beyond, but what lies within. Because in the end, Webb didn't just find water around stars or carbon dust in the dark. It found meaning in motion, structure in chaos, and purpose in the very act of existence. It revealed that everything, from the birth of galaxies to the beating of our own hearts, is connected by the same invisible thread. The telescope had reached across 13 billion years of history, and what it found wasn't just the universe's past, it found our future. And as that realization spread across the world, people everywhere began to look up again, not with fear or longing, but with recognition. The stars weren't distant anymore. They were home. The James Webb Space Telescope didn't just stop the world. It reminded us that we were never separate from it, that every question we've ever asked about life, creation, and purpose has been answered already, written across the sky, waiting for us to finally understand. So when you look at the night sky now, remember, you're not looking at something out there. You're looking into a reflection of yourself, scattered across billions of light years, breathing, glowing, and waiting for the next moment of discovery. Because somewhere, right now, another world is being born. Another ocean is forming in the dark. Another spark of life is igniting, guided by the same forces that made us. And when Webb looks again, it might not just show us where we came from. It might show us who we're about to become.